Hello, thank you everyone for attending the demo video for the virtual showcase. My name is Hajara Wallman, and my team includes Dewey Morris, Jackson Wu, Hazar Criollo, and Alex Batista. Our project is METIS, Modeling Emotions for Training in Immersive Simulations Teacher Edition. Essentially, a simulator aimed at training teachers for students with behavioral management issues. You're about to see a demo of METIS. The user will interact with the application and respond to the scenarios that will be used as training data. The application ideally thrives with a superior, monitoring the options the teacher in the training chooses. Once reaching the end of the scenario, it will then convert it into useful feedback and an overall score that the user can analyze and use to improve their teaching methods. The 3D models and facial expressions of the students were created using Make Human, an open source tool for creating custom humanoid models. And now off to Lisa.
Thanks, Ajar. In this scenario, I'll be taking the role of a teacher in training. This scene, as you can see, is from 6th grade AVA selection. METIS currently has one other 6th grader and also a 1st grade scenario. So let's begin. It says here that the class is getting ready for lunch, and we are asking the students to do a task. So let's begin.
I don't know.
So it looks like she needs her book for the assignment, and looks like she's not prepared, so I'm going to tell her to look for the book.
What should I do then?
Let's see, I have the option of tell her to look or to ask one of her classmates. As I would say for her not to disturb anyone else that is currently reading, to look for her own book. As you can see, her facial expression changed. She is angry. That might have not been a good decision, but let's continue. Let's see, you may as well clean up your desk. Don't forget to check your backpack, or move to Ava's desk to help her look for a book. I'm going to tell her that she should clean out her desk to find her book.
Found it.
There it is. So that's a good thing. She found it was in her desk. I'm going to tell her that that's great. Unfortunately, it is time for lunch, so she would have to use the free time that she would have had to catch up, and I'm going to let her know.
That sucks.
Oh no. So that was one of the many endings that we have in this METIS simulation. This was one of the negative endings. Unfortunately, it's not always obvious what the best decisions are. I might have made decisions that were best for the class, but not necessarily best for Ava. So thanks to this simulation, I can run this again with well over 50 decisions leading down different paths. Now that the demo's over, we're going to talk about the optimizations implemented to help us achieve our goals for the semester, which led to what you see here today. I'll be handing it off to Jackson to discuss how the character models were optimized to make the scene more performant.
Thanks, guys. So one of the primary approaches we took to achieve character complexity reduction was to rework all the background students within each of the scenes. So to do that, we use a free 3D modeling software called Make Human Community that allowed us to create and export all of the students used in METIS. All the models that were given to us in the original project use this software, so we just continued to use it to refine them. They were also approved by FIU's School of Education and Human Development to be used for the simulation. I just want to reiterate that our goal was to augment the already existing background students so that we can optimize the performance of the build in the WebGL platform. Initially, all of the background students that were created using this program had the skeletal rig called Default No Toes, which was designed to include detailed fingers and facial bones for advanced animations. The skeleton contains a total of 137 bones. Since the purpose of these background students are to emulate a realistic classroom environment, they won't be producing any facial animations, only specific body animations to replicate a student's actions during class time. So our solution was to use a more basic rig to animate, since these students would most likely just be doing idle animations. And to achieve this, we used the CMU MB rig, which only contains 31 total bones. Using this new rig amounted to a total reduction of 72% in bones, which would output a massive decrease in loading times of the project and the number of computations required for each animation. Now here, I'll show you the visual differences in Blender, which is another 3D modeling software we used to review and rework textures of the models. Here you can see the original model of the student on the left side, which has a total of 111 bones, as you can see on the bottom right. Give me one second. Right here, 111 bones and 149 vertices. While in contrast to the right side, there is a total of 31 bones and 62 vertices, as you can see here. Which again would serve an overall boost in performance for the build. These animations were also tested in Unity using the newer rig, and they were proven to work flawlessly, as you can see here in this animation. Alright, and now I'll pass it to Dewey to talk about animation optimization with animation controllers.
Thank you, Jackson. We have made changes to the project's animations. So every student game object would have the same animation controller, which had more nodes or states. This is a picture of the old animation controller before we made our changes. Every frame, Unity would check conditions given to each state to see which animation to play. There are also nested states, which also add to the complexity of Unity checking the states. Student game objects would have animations they wouldn't really use, so we decided to separate the original animation controller into relatively smaller animation controllers based on the type of student. We have 3 classroom simulations. We separate students to 3 types: main, assist, and idle, depending on if they are the main focus student or if they do anything with the focus student. Smaller animation controllers meant resource efficiency in each scene due to Unity having to make less Boolean checks in the animation controller. And now I pass it on to Alex to talk about memory optimization in the project.
Thank you, Dewey. Part of the optimizations for this project was size reduction and memory pool reduction wherever we can. Firstly, for the size reduction of the build, we used a system recently introduced into Unity called addressables. Prior to this was asset bundles if you're using an older version of Unity. Addressables is a system that Unity created which allows you to mark assets within Unity from scenes to textures, which will remove that marked asset from the build. This simplified the process of separating and bundling assets into chunks that can then be sent online for retrieval. The system is fairly automated with only requiring a few things to be set up. 1. The FTP location in the profile settings for the addressables, see right here. And 2, a proper labeling for the assets so that we can try and retrieve the assets from the FTP with complete accuracy, which we'll see right here. Because of the system removes the assets from the build takes very little time to start the scene, and while loading can grab the assets needed, for us I grab the assets prior to loading and load the scenes once the assets are completed in code. Next up is scene performance optimizations. In the scene, we have a lot of materials in play, and because of this, we noticed through profiling that there were many draw calls for each unique material applied to the environment. To simplify this and gain more FPS from each scene, we utilize GPU instancing. This allows us to pull all materials into a singular draw call. This works to our benefit as this means that multiple same material types were now reduced to a singular draw call and singular memory load replicated across different agents on screen. This was applied to all skin colors, hair colors, eye colors, clothing, desk, books, etc. We were immediately able to raise our FPS in editor from 30 to 40 to 50 to 60 prior to updating to URP.
Thank you, Alex. This was a concise overview of the optimizations we implemented in METIS. While there are more things that we couldn't fit into 10 minutes, we will gladly answer any questions you may have. We appreciate you watching this video and thank you for your time.